Hello, everybody. This is Gigi from Kauai Community College. In this video, we will be studying power series. Okay, so power series are of the form C sub k times x minus a to the k power. Now, the C sub k, that's what we normally refer to as the coefficients of the power series, and the A is the center. Okay, so when looking at a power series, we, or any series in general, right, we want to know whether a series converge and when it will converge, right? So looking at this here, the series is written as a function of x, meaning it's written in terms of x, so that the interval of convergence will depend on the values of x, and that's the x values that are near a, right? So because that's the center, a is the center. For example, we say, let's say if the center is at 2, okay? And so this is just kind of demonstrate the definitions or what the wordings mean, right? So suppose the radius of convergence is 5, okay? So you could go 5 to the left or 5 to the right of the center 2, so that the interval of convergence would start at on the left at -3 and on the right at 7, right? Now, when looking at the interval of convergence for the radius of 5 and center at 2, and we would need to take a look at the endpoints, meaning will your series converge at -3 and 7 as well, right? So that's basically the idea of what we are doing in this lesson. Given a series, a power series, can we find the radius of convergence and the interval of convergence? Suppose you have the series here. Okay, now again, let's take a look at that. I think visually the chart helps me figure out what I'm doing. So again, let's take a look here. Your A is 2, right? X minus a to the k power. So A is 2, okay? And we're trying to figure out what's the radius of convergence and then what is the interval of convergence. Looking at this series, I think the ratio test would be best. Okay, so I think most often when dealing with power series, we are looking at either the ratio test or the root test. All right, so ratio test said take the limit of a sub k plus 1 divided by a sub k, right? And here, since we have a fraction, division means to multiply by the reciprocal. Cleaning this up, we have -1 multiplied by k plus 1 over k, and then there's a 4, and then there's a x minus 2, right? Now, when k goes to infinity, we can see that k plus 1 over k is going to 1. And then the absolute value of -1 is 1. So that gives us 1/4 multiplied by the absolute value of x minus 2. The ratio test said that the series will converge if this right here, which is our L, our limit, is less than 1, right? In between 0 and 1. So that means that the absolute value of x minus 2 is going to have to be less than 4. So we are looking at the radius of convergence being 4, and the endpoints is going to be from -2 to 6. Okay, what question do we need to ask ourselves before we write down the interval of convergence? What happened at the endpoints? So at the endpoint -2 and 6, we just have to plug those x values into the original series. And when we do that, when x equal to -2, we simplify, clean up, and we end up with the series of from 1 to infinity of k. And that obviously diverges, right? Because divergence tests will say the limit as k goes to infinity of k is going to be infinity, and it diverges. Now, when x is 6, we will have, well, when we take the limit as k goes to infinity, your series will bounce from -infinity to +infinity, meaning the limit doesn't exist, and a divergence test will say that the series diverges. So open circle at both -2 and 6. Your interval of convergence go from -2 to 6, not including the endpoints. And your radius of convergence is 4 with the center at 2. All right, now let's take a look at this next one here. Again, I'm going to go ahead and put up this graph here. The question is, where is your center? Okay, now remember, the power series definition states that it's going to have to be x minus a, right? So the coefficient right next to the x is 1, not 3 in this particular series on how it's written. But if we revise that and factor out the 3, we would see here that this is going to be x plus 2/3, right? That's what that is. And then that's to the k, and this is going to be to the k power there. So this 3 to the k right here is going to be part of the coefficient, right? But what we are interested in is, where is our center? So looking at that, our center is going to be at -2/3, or basically you just look at this right here and you would say, when is at 0? And that's your center right there. So -2/3 is your center. Okay. And again, we are looking for radius of convergence so that we can find out what interval of convergence is. What test are we going to use? It has factorial, so that's a good indication of the ratio test. Again, right here, taking the ratio test, simplify that, and we can see that the limit as k goes to infinity of k plus 1 is going to be infinity. The question is, what is the absolute value of 3x plus 2 that might make this converge? Well, if the absolute value of 3x plus 2 is anything except for 0, then that number multiplied to infinity is going to be infinity, so that the series will diverge, right? Now, but if 3x plus 2, absolute value of 3x plus 2 is equal to 0, then 0 multiplied by infinity is going to be infinity, and the series will converge. So basically, the series will converge when x is -2/3, right? So we would say, looking at this picture again, we would say that the radius of convergence is 0, okay? And the interval of convergence is just that one point right there, -2/3. So you list out the 2/3 as a number, and that is the interval of convergence, just 1 point. All right, example 3. Again, your center is 5/4. Okay. And you have 2 to the kth power. So that is a good indication of a root test, right? So taking the kth root of that, simplify, and we can see that this is going to 1/k is going to go to 0. K to the 0 power is going to be 1. So then the limit as k goes to infinity of the kth root of a sub k is going to be 2. Okay, and now this right there again is our L, And the root test said we want our L to be less than 1. That means that for x minus 5 in absolute value, going to be less than 1/2. So 4x minus 5 will be in between -1/2 and positive 1/2. Solving for x is going to be in between positive 9/8 and positive 11/8. So the radius of convergence in this case is 1/8, right? That's the distance from the center to the endpoint. And 9/8 to the left, 11/8 to the right. And we are again needing to consider whether the series converge at the endpoints. So plug it in 9/8, we simplify and end up with a alternating harmonic series. And we know alternating harmonic series converges. At 11/8, the other endpoint to the right, we plug in 11/8 for x, simplify, clean up, and we end up with a harmonic series, and that we know diverges. So closed on the left, open on the right, the interval goes from 9/8 to 11/8. All right, one more. Well, A is 2. And looks like the root test would be good for this type of series. Take the kth root, undo kth power. We have that, and I don't mean to say that. I mean to say x minus 2 absolute value right there. Okay. And this, when k goes to infinity, this is going to go to 0. 0 times any number is 0. And 0 is definitely less than 1. So the series converges no matter what the x values are, right? So our series convergence, interval of convergence does not, in this case, does not depend on the x value. So we would say the radius of convergence is infinity, is infinite. So that interval of convergence would go from negative infinity to positive infinity. And that is it.